Alright, here we have a cross-section of a beehive that consists of a bunch of small adjacent hexagons. And the middle hexagon we're going to call the first layer, and then the 6 hexagons surrounding it we'll call the second layer. And the question asks, if a beehive has a total of 8 layers and each hexagon has a bee residing in it, how many bees are there in the hive? Alright, well, we start with 1 hexagon is the first layer. Let's see if we can find a pattern. Alright, so if I call this the layer and this is the number of hexagons, okay, and we'll keep track. So first layer we have 1 hexagon. The second layer we add 6 more hexagons, 1 for each side. So 1 layer, 1 hexagon. The second layer we add 6 additional hexagons. So we have a total, I should say this is the number of hexagons per layer. Okay. And then if to get the total number of hexagons, we could just add them up. So, but I'm going to look for a pattern here in the hexagons. So let's look at and see what would happen if we added another layer. So we would add up 1 here, right? So we'd have it coming off like this, and then here's another one would come off like this, and a third one, and a fourth one, and a fifth one, and a sixth one. Kind of running out of room down here. 7th one. We'd have an 8th one in between here, and a 9th one, and a 10th one, 11th, and 12th. Okay, so you can kind of see, I'm not drawing the whole hexagon out, but you can kind of get the idea here of what they would look like. Yeah, that would go that way, that would go that, and that. Okay, so you can see where the additional 12 hexagons would go. So in the third layer, we have 12 hexagons in that layer. Okay, so 6 more. Okay, but here we had 5 more. So we still got to see if we can find a pattern. You might notice too that in the first layer we just have 1 hexagon, and in the second layer, if we were to like connect the centers of all of these hexagons to actually draw another hexagon, you can see that we have 2 hexagons per side and 6 corners, right? So we have 6 sides, 2 hexagons per side, so 6 sides, 2 per side, and then we'd have to subtract, if we were going to add that up, that would be 12 hexagons, but we know that to do it that way, we're double counting. If we take 2 times 6, we double count the corners, so we have to subtract the number of corners. So we have 6 corners, okay, which gives us the 6 hexagons in the second layer. In the third layer, I could draw another hexagon here, and you could see that we would have 3 hexagons per side. I'm running out of room, but actually here I could scroll down a bit maybe. So we'd have 3 hexagons per side, but we still have 6 sides and 6 corners. So we could think of the third layer. This one up here was the second layer. We could think of the second layer as having 6 sides with 3 hexagons per side, and then we subtract the 6 corners, and that would give us, whoops, that should be at times, so that would get 18 minus 6, which is equal to the 12 that we got, right? So we could follow that pattern and see what the fourth layer would have. So the fourth layer would again have 6 sides, but I'm not going to draw it out. You can kind of imagine. It gets kind of messy for me to draw it all out. We have 6 sides times 4 hexagons per side, and then 6 corners. Okay, so we get 24 minus 6, and so that gives us, what, 18? So it's just another 6. You could also think of it as factoring out a 6. So we could, because we have 6 sides and 6 corners, you can see that it's like, and we let the number of sides be n, okay? Then you've essentially got n minus 1 times 6 for each layer. That holds for all the layers except for the first layer, right? Because if we just have one hexagon, and if you put in 1 for that, you get 0 hexagons, but we actually do have 1. So for all of the layers, we can I could write this as the nth layer. This equation would hold here, this 6 times n minus 1. So the 4th layer has 18, the 5th layer would have 6 more, which would be 22, okay? So, so you can see a pattern going on here. Oops, I think I messed up somewhere. That should be 18, shouldn't it? I was adding 6. Not doing very well. Okay, so we said we had 18, and then if we add 6 to that, we get 24. Okay, that makes more sense. All the way up to the 8th layer. I could write all the numbers out, but the 8th layer would have 6 times 7, which is 42 hexagons in it. And in order to figure out the total number of hexagons, we could add these up, or we could recognize that this is a arithmetic sequence, at least past the first one. So you can see, you know, every time we're adding 6 more, and so on. So if we add the arithmetic sequence from 6 up to 42, then add 1 to it, we should get our answer. Okay, because we get the 1 for the center, and then beyond that it's an arithmetic sequence. So let's figure out what that is. All right, our handy dandy trick for adding an arithmetic sequence is to take the first number, which is 6, plus the last number, which is 42, times the number of numbers, which in this case we're going from the second layer to the 8th layer. Okay, so we have 7 layers here. So, and divided by 2. So it's essentially 48 divided by 2 times 7, right? So 48 divided by 2 is 24, times 7 is what? That's 28, 14, 168. Okay, that's layers 2 through 8. And then we'd have to add 1 more for the first layer. So we have a total of 169 hexagons. And the question asked how many B's there are, and we have a B residing in each hexagon, so we have a total of 169 B's.